Hello, everyone. It's a great pleasure for me to be here back 20 years after my first experience of Singapore. Many things changed. Many things changed also in the IoT. I've been an engineer in M2M, electronics and telecom, and I could say that the revolution of IoT is very surprising by many extents. So over the last 10 years, I've been with Semtech, and with the LoRa Alliance. Here I am the chair for Smart Water and Energy Workgroup. It's my pleasure to have dear members of LoRa Alliance that will present for you today amazing success stories from, let's say, small size deployment to very large and massive IoT deployment for utilities in water, but also in smart grid. It's true that LoRa is a technology that is today available for many use cases, and we will, in the next hour, cover mostly about utilities applications. So what are the, let's say, translation from a technology benefit to a real value for utilities? Some few key points is related to the open network specification or open network protocol that is defined and maintained by the LoRa Alliance. That's the main job of LoRa Alliance today. And since 10 years, let's say 11 years, because LoRa Alliance was created in 2015, we have the same protocol evolving, enriching by new features, but still delivering the same upside for utilities and for many customers to create highly scalable network and very cost effective, because if it's open, the technology can be adopted by many device manufacturers for gateways as well for devices, and then system integrators can assemble, and you have a total open choice. There are also a second advantage of different class of communications. Maybe some of you already know, but LoRa modulation was designed for the deep indoor use cases of smart water meters. At that time, 20 years, let's say 2012 to be very specific, when LoRa was created, invented, it was designed to tackle the limitations of wireless and bus. FSK modulation. So LoRa has been properly created to ensure low power, long range, and to allow end device to have simple communication, class A, but also capacity to receive downlinks from the network. Class B with a beacon, class C in continuously mode, the device can communicate, and then they, of course, consume more power. That's typical for smart grid application, for example. So the main advantage of these different class of communication is it gives more flexibility. It's also allowed to have a reliable delivery of connectivity. For example, utilities will ask for a reliable meter reading rate of 98% or more, meaning daily data must be delivered for each meter by 90%, 95, 98% are typical requirements. So that's how, for creating a LoRaWAN solution, utilities expect operators to secure SLA, to secure quality of service, and they expect the ecosystem to collaborate to achieve that goal. Low power, deep indoor, long range, they are the key technology features of LoRa modulation that profit to LoRaWAN, but without the adaptive data rate, which is a mechanism in the LoRaWAN network server, you could not efficiently control the power consumption, and you could not optimize the battery lifetime. This mechanism is very specific to LoRaWAN. It helps to make a good trade-off between consumption and sensitivity, meaning every device on the network will be controlled by the network server, ensuring a maximum lifetime. That's the advantage typically for gas or for water meters. Last, the LoRaWAN certification is a principle that gives a total credibility, total guarantee of reliability and interoperability for the end customers. They have here with which is the ecosystem that is opening, that is giving an open choice. It's also giving a long-term value because utilities, they can go for a contract. At the end of the contract, they can eventually change operator, or they can eventually replace some devices because of battery end of lifetime, but they can continue with the same system and they are not dependent on one vendor only. To illustrate that, we will have use cases today showing deployment of different size of network from one building to cover some meters to large-scale deployment in Indonesia. Also, in other examples, we will have example from UK. So to explicitly say LoRaWAN first use case is smart water metering. So we have many references, but in different countries and of different size. Not only smart water, but also smart grid monitoring with examples given by Netmore, and also other applications that are beyond the smart metering. I would say that when I look at the marketplace of LoRa Alliance, I can see more than 100 of devices of different kind to support water management. It means water pressure, water flow, water leak sensor, etc. This is also illustrated by the LoRa Alliance infographic, where we tried here to regroup different use cases from metering to also smart grid for gas as well, for solar panel control. We have impressive examples of solar farm panel monitoring. We have also for protection of water generation with pumping system, sewage, water treatment, wastewater, etc. So with the promise of this open network protocol, with the flexibility of network models, the utilities can invest with LoRaWAN to create solutions that can be applicable in different countries and that can support all these applications. Here, it's sorry for that, but it's not a complete list of the members. It's very focused on Southeast Asia and utilities. I'm giving examples of members active along the value chain for smart utilities. And I will invite a couple of minutes Netmore to speak up. Then after WNE, Itron, and Kerlink, and finally Sindcon, to show examples of members where they have a clear focus in specific part of the value chain, but together they can combine and they can also support utilities for various applications. So now I will ask for Netmore, Sourmack, to speak up.
Thank you, Remi. Thank you, Alper and Henry, for your talks already. So, hello, everybody. My name is, sorry, you can all hear me okay? Yeah? Okay. So, my name is Sourmack. I'm the Regional Sales Director for APAC at Netmore. Today, I want to talk about how LoRaWAN is enabling real-time visibility across the power grids, especially in areas where utilities have traditionally had visibility issues, especially the low voltage network. So for those not familiar with Netmore, we are a global IoT connectivity provider. And we really primarily focus on utility business. And as you can see, we're trusted by major utilities in water, gas, and electricity. We have about just over 10 million connected devices and contracted for up to just over 15 million. We operate across 50 countries, and we have offices all over the world, including the Asia Pacific region, including in Singapore. So one of the common questions we get is from utilities: why LoRaWAN over, for example, instead of cellular, right? So the first one is really deployment simplicity. There's no SIM provisioning management. There's minimal site dependencies, and this allows for really rapid deployments where coverage is required. The second one is just extension on the coverage because LoRaWAN has really it works well in extremely difficult environments, which are the sort of environments that utilities are faced with, whether it's underground, basements, substations, low voltage cabinets, and so on. LoRaWAN really performs well under these environments. The third is battery life. A lot of the power grid use cases require at least 5 to 15 years battery life. So they need to operate without maintenance, changing batteries every year, and so on. So again, this is another key advantage of LoRaWAN because it's so ultra low power. Also cost, from a cost perspective, you avoid the SIM connectivity cost. You also have reduced infrastructure and maintenance costs. And also another important factor is that, as it was already covered, that LoRaWAN has Class C communication. So it really enables near real-time monitoring and rapid event response. And the last one is actually I'm finding to be becoming quite important for utilities is that they don't want to have dependency on cellular operators. They want to have some level of control over the network, over the coverage, over the security, where the data is hosted, and so on. So those are kind of like the key advantages that LoRaWAN has. On the right, we have the Netmore ThinkPark platform. So this is the IoT connectivity platform which enables all of this. It controls and manages the devices, the gateways, acts like a mediation layer, enables bidirectional routing of the messages, enterprise grade or carrier grade security. And for utilities, we built a lot of specific industrial protocols to allow easy integration for them, like OPC UA, Modbus, MQTT. So it makes it very easy for them to plug it into their existing networks. So we're now seeing LoRaWAN used across a wide range of various use cases. So it's not just smart metering anymore. It's low voltage network monitoring, conductor down monitoring, pole tilts, substation monitoring has become a very popular use case. Now, the key point here is that, yes, there's a lot of use cases supported, but the important message is that LoRaWAN now acts like a horizontal connectivity layer where you can just reuse this connectivity network to plug in different use cases. So you might start with conductor down monitoring today, and then as time goes by, you just start plugging in other use cases on top on the same infrastructure. The low voltage, one of the biggest challenges utilities face here is the low voltage and the grid blind spot. So the grid is really changing rapidly. There is now EV charging, rooftop solar, there is batteries, and these are all creating like bidirectional power flows and increasing the complexity at the edge of the network. So, and at the same time, utilities are under pressure around safety, reliability, performance, and so on. So the device you see on the right there, PowerPilot, it's one of our partners and helps really solve these issues. It's become a very powerful solution. It combines Class 1 metering with embedded LoRaWAN connectivity communication, and it really helps provide visibility across the low voltage networks. Utilities can now detect things like conductor down events, monitor voltage imbalances. They can improve phase balancing and optimize the asset utilizations. What is particularly exciting is that, a few years back, these were all theoretical use cases, and now they're actually being proven in the field, being deployed by utilities on live networks. For example, PowerCo has been one of my customers in New Zealand, the largest electricity distributor there for more than 5 years now. And they've achieved like 100% detection rate during live conductor down scenarios across multiple fault scenarios. Horizon Power in Australia, Western Australia, also has identified hidden network issues such as voltage imbalances and transformer utilization issues, where previously without this sort of technology, where they had zero visibility. Oh, sorry. And then the last one is West Power. They were also able to demonstrate a real-time fault detection during a live network issue. And what they were really impressed with was that they've identified this fault within seconds. How am I doing for time?
Finish. Please finish.
So last one, guys. Sorry. So quickly, these are just some pictures of actual deployments where we've got gateways on poles, so power utilities can use their existing assets to create coverage at the edge. And these are just examples of sensors deployed across the low voltage network. So I'll stop there. There's not much more, just what customers are saying. Please come visit us at our booth, contact me via email or connect on LinkedIn, and thank you.
So good morning, everyone. My name is Tuan. I'm the founder of WNE. WNE is short for Water and Environment Solutions Singapore. And it's a pleasure for me to be here with you all. And thank you, Remi, for connecting all of us. So my case, in an event like this, we're talking about the future of smart city, futuristic of a smart building. But for majority, the actual challenge for us, and also the challenge and the opportunity for us is more on the existing building that where we're actually living in and working every day. And today I'm going to talking about our case and how WNE did successfully connect all of the electricity and water meter with 99.9% reliability successful rate with using LoRaWAN in a high-rising building. So before we go to the case, just briefly to introducing about WNE. So we are software and IoT service provider for the solution provider. So we have a A10 metadata management system, and we can do access management, tenant management, and we have AI ready, which means connect to Cloud or ChatGPT to do any of your report, alert, and data analysis. Then we have the beacon line. It's like a universal bridge IoT to can read any type of different method protocol, and so that's way easily to plug and play to any existing method to transform it into LoRaWAN and platform data. So this is my case study. This is the Lancaster surveyed apartment. It's a luxury apartment with 20 floors, and you have around 150 units of apartment, and in the center city of Ho Chi Minh City. So the challenge for us is how to digitalize the entire electricity and water in the building without or with a very minimum disruption to the operation and the living of the tenant and resident. And we have to visualize all of the energy and water in the same platform. And the last one is automate the building. So we have did this. The first thing first, we have to choose what kind of technology we have to do. So with a minimum disruption, then we cannot use wiring because you have to touch into the existing infrastructure, your cabling, this and that. It's not possible. So left out with 4G or NB-IoT and LoRaWAN. Then 4G and NB-IoT, this building, mostly the vertical technical room is in the same vertical in high rising. And they normally at the very corner of the buildings and where you cannot reach 4G. And if you ask the telecommunication, just hey, open more or enhancing the 4G or NB-OT in the building, then it's not likely to make it happen. So end up with us using LoRaWAN is the most efficiency and suitable. And also at the same time, the battery life for water matter. We wanted more than 5 years at that time. So and yeah, so I think that's why we are choosing LoRaWAN, and we believe this the most suitable one. And if you can look at this, we deploy all of the 150 electricity meter plug and play within less than a week. We just plug 30 device of our BK device and plug into the existing one. No disruption, nothing. Within less than a week, we can connect all of them. And for water, you can see the water picture here. They actually inside the wall and with the metal box. But imagine LoRaWAN, we have no problem with that as well. So I think this is one of the. So eventually, one gateway, LoRa gateway, can reach 5 to 7 floor up, 5 to 7 floor down. So at the beginning, we only need to use 2 gateway for electricity meter, 2 indoor gateway for all. And then, but because of the water, they are scattering in front of every household, every tenant. So we have to install extra 2 more gateway, and that's it. And we're able to successfully deploy the whole things in less than 1.5 months. And so the benefit of this is unmatched data reliability. So all of the data is transmitted through using LoRaWAN with 99.9% of data transmission success for all of the 320 end nodes. And imagine this, it's in this project is deployed in 2021, and now 2026, we have no problem whatsoever with the data and the transmission. For the building automation, we eliminate all of the human manualing process, all of the paperwork, and also all of the back and forward between the tenant, because this is a service apartment, right? So you may not have 30 days, you have 7 days, 10 days, and someone will read it. So all of the building is automated, so remove all of the problem inaccuracy, 100% accuracy, because we read exactly the data from the meter. So it's also eliminate all of the eliminate all of the conflict between the tenant and the management. So all of them transparency, both of them can see how much they use every day. The management also able to reduce their consumption, any leakage detection immediately, abnormal in time. So overall, I think for the last 5 years, almost they can reduce more than 15% of their energy consumption, their cost and operation. So yep, I think that's pretty much my case. Thank you very much.
Yeah. Itron?
Hello, good morning, everybody. Can you hear me? Okay. Thanks for giving me this opportunity. Remi coordinating and LoRa Alliance giving us this opportunity to come and present here. So we have pretty big presence globally. I'll just run this to. We have global presence. We have manufacturing across in US, Europe, and Asia. So our manufacturing hub for Asia is in Makoendo in Indonesia, where we do our metering and our communication modules. And then we have ultrasonic meters, which are embedded communication, which we have just started manufacturing in Asia. Previously, it was being done in Europe. So this is where we are. We have, in terms of AMI networks, and primarily it's LoRa, which we have been using in Europe. We have almost 3 million meters already deployed over a couple of years, and that's giving the benefits, and we'll come across what benefits we have been having since then. So just talking quickly, going about how Itron compares to the and benefits to the utilities, because we have end-to-end solutions. Down there, you see the lower physical layer, which is electricity, water, and gas meters. And then we have communication, it's AMI communication. We are agnostic, but because in water, it's primarily LoRa. And then we, on the top of it, the analytic part, which is more AI enabled. And you have, in terms of water, it's about reduction of non-revenue error, which we are trying to do we try to bring end-to-end solutioning, and we have some cases in Asia already where we have DMA management, where we are doing hydraulic balancing, and then eventually doing NRW and balancing on frequently basis. The need for doing this analytics on real-time basis is primarily coming, and that's where we need MI, and that's where we need LoRa for communication on domestic as well as CNI customers. Primarily customers in CNI because the revenues are pretty high. So we know that NRWs in most of the Asian utilities is pretty high, 25 to 40. In India, we have come across to 57%, and we see that a lot of concession projects which are being awarded across Asia are having a SLA up to 20-25%, and we have seen that reduction happening with adoption of technologies like LoRaWAN, where you have communicating meters, where you can get hourly data, and when you can really do real-time analytics based on that hourly data. So and it's just not about, so in Asia, we have heard from utilities that the tariffs are low and investing on AMI is pretty difficult. But I have personally seen when we go and talk to the customer or the utilities, it's just not about invoicing to the customer, which could be low in most parts of Asia, but it's about saving the water, which is becoming more and more, important across this part of the world. We have seen scarcity happening in cities like Bangalore and bigger cities in Asia, Manila, and everywhere. So the importance of just not limiting ourselves to invoicing based on the AMI or AMR reads is also about bringing in AI and bringing in technologies which can really help you to save water. That's the interest which Itron brings in as a complete stack, end-to-end stack. So coming back to the product which we are today using for LoRaWAN is Cybele 5, which is a electronic module that is attached to our mechanical meters, a range of mechanical meters, starting from DN15 up to DN150, and these are all LoRaWAN capable. So as I said, in Europe we have almost 3 million meters, and in Asia we are looking at more and more deployments happening. So probably we would be shipping out another 100,000 Cybele 5 across this part of the world. Going beyond, some of the more mature utilities are going to ultrasonic static meters because of various other reasons and the capability to invest in static. We have embedded communicating modules in our ultrasonic, which we call Intellis W source. The big thing which is very important and which Itron as a company is more dedicated is about committing the quality. So the battery life which we commit here is around 10 years for our Cybele 5 module, and that helps utilities not to replace meters over and over again, and you can really use them. It's all the workmanship which is required on the hardware replacement is really not required there. With the battery life commitment, you can really use you can read hourly data, and the whole objective of analyzing that data is met with this. So we have a solution which is called Temetra Analytics, which is a dashboard. It's an MDM but dashboard, which gives you analytics on real-time data, based on real-time data, which we can do DM analytics and hydraulic balancing. So I think this is the last slide for me. So Semtech is one of the use cases. Remi said that we should bring one of the use cases which we have been, where we have deployed AMI meters, has been running for a couple of years. So Semtech in UK is one of the largest deployment, which we have already 400,000 meters, and it's spanning because this is a concession project for Semtech. So we have reduced water by 6 million liters. Obviously, this is very advanced utility per se, but and there have been identified leaks for 145 days faster. So it's important to identify the leaks, as they happen, and not really read the meters. If it's AMR or manual reading, it could be one month that you go and identify the leaks. It's important to have them on real-time basis if you want to really save water and have the consumer served in a better way by the utility. So whole objective in investing in AMI is just not about the whole message I want to give here is not just investing in AMI modules which are LoRaWAN enabled. It's just not about reading the meters and invoicing them on the time. And that's not a big concern in Asia because domestic tariffs are very low, leaving Singapore aside, but generally it's very low. So the intention should be an intention for an utility should be to give analytics, real-time data analytics, consumption usage, historical data analytics, which I have a real-time experience in Delhi when we started putting AMR meters. Obviously now a lot of them moving to AMI. The consumers said that the bills which they are getting has just gone up because of the AMR. But when we showed them that there were leaks and we gave them historical data, the bar charts and everything, they could really figure out that there are issues which is not about the utility, is about why there's been leakages inside the houses, and they could really, or maybe they have been out for holidays and there's been no consumption. But so that's important. Analytics is very important part of investing in a good quality communicating meters. That's the whole idea we should have. The other thing would be that when you use Itron AMI meters, which we have seen in these developing countries, there's no LoRaWAN infrastructure which is available when the tenders come out, and tenders generally they do not have. We are trying to educate the utilities, but they don't have the LoRaWAN infrastructure in the place because utilities are used to just tendering for metering and handheld unit, all that stuff. So what we are telling them is go and install meters which are AMR enabled and can be upgraded to AMI without disturbing the meter itself. So you just put on, so you read the meters on AMR today, but you can eventually go to AMI when you have gateways and you have the survey done by some LoRaWAN provider. So that's been catching up quickly, and that's been really recognized by these utilities, a much better way to install AMI network. I think that was the last one. Thank you.
Thank you everyone for coming today. I'm Treza. I'm the sales from Kerlink. So my journey starts when I go with Kerlink. They not teach me about the technology first. They teach me about the value first. What we are trying to deliver, what is the missions, what is the visions. And the rest is the story that you can explore with us, and how we assimilate to your IoT journeys. For every customer is different. The motivation is different. Now I would like to talk about the utility motivations. Itron already talked about the importance, and then Actility already exposed you to with the technology. And Remi also already told about the story of the LoRaWAN technology, how it can help the utility. But the one that I witnessed myself is Tuan journey. Like we start together, but he's the first one. I would like to speak in my slide, but actually he already represent here. So I will bring. It will always come with what is the problem with the utility, right? They will take the water somewhere, they will take the electricity somewhere, they will generate it, and some will make it along the way. It depends on the areas where they will get the water first, they will treat it first, and they will distribute. And along the way, they will face some problem with the utility, what the condition of the piping, and some is a legacy. This coming from the Dutch colonialism, right? They still have the iron piping, copper piping, and now with the technology advance, it's already moving for the PVC. And this kind of networks, some of the utility even does not aware. So we always start by knowing the point. Where is your utility located? Can we transform it digitally? And sometimes it's quite challenging just to know the point. They will address that. Do you remember this somebody house? That's where the piping is. They don't know the grid. They don't know the location or latitude. So after we assimilate in the journey, we put into actions for the planning. We knowing the point, we plan the deployment for the LoRa gateway deployment. This needs to cover all the point that they plan. And then we deploy. We deploy at the suitable height to cover this at the planet, and then we test. After that, we optimize with the optimization tools. The importance of the optimization tools is not only about feasibility, it's about control. The control that you have, what is the damage, the trend, everything, you will have the feasibility from all this insight and data point. Now I would like to talk about the recent deployment, right? The issue is one of the largest utility in Indonesia, in Jakarta city. They have also that kind of issues, the data collecting challenge, and also the limited connectivity in some areas. And some areas are quite dense. It's unpredictable. The growth of the buildings, everything come into really fast natures. So what it needs, again, with the IoT journey, we try to assimilate. We try to ease them into the deployment, into the technology, and it needs dedications. That's why you need to be present for them. And you need to be available for all the questions, no matter how small or big. And this is one of the journey. It's deploy with our partners. It really matters that I mentioned, the one that deploy all of this. This is Michel, one of the experts from Kerlink. He flew from Rennes, France, to Jakarta to accompany the deployment, to see where it located, how it deployed, and also the challenges of the gateway deployment. We need to get creative where to deploy the gateway, and even we need to answer the locals, right? The local asking about where are you come from, and they even doesn't know about the country, right? He asking about his soccer players, and fortunately, Michel can speak the lingo of the locals. So this is also important that we cater all of these problems and issues. So if you want to know more about these kids, please visit me in the booth. I'm happy to answer about the questions. Thank you.
Good morning, everyone. It's my pleasure here to present. Oh,
The
sorry.
green button.
Green button. Okay. Okay. Good morning, everybody. Yeah, it's my pleasure here to introduce our success story in smart water metering in Jakarta. And my name is Deyu. I'm from Sindcon. And today, before the introduction, I would like to introduce a bit about the Sindcon. And we established in 2015. And from our very beginning, we very focused on LoRaWAN solutions, especially from the smart meterings. So until now, we provide end-to-end solution to our customers in smart metering and smart sensors. And we are also the authorized partner of the Deyu metering in Singapore. And our largest project now ongoing is in Jakarta for the Panjaya, the smart water metering. So the target for this project is we are going to deliver about 1 million devices until 2030. And until now, more than 200 devices already been delivered and 100,000 already been installed. Okay, so for the water metering, for the water utilities, the most challenging for them is the non-running water. So this is because of the large population increase over the years and the aging of the infrastructures like pipings and leakings. Okay, so the limitation for existing almost all the utility is the limit visible data for them. So they don't know where is the loss of the waters. So overall, I think average for all over our Asian countries, 30 to 40% the water loss is very common. So this is a very common data for all our neighbor countries in Asian countries, except Singapore. Singapore will be better. So the only way to solve this problem is to convert to digital transformation. Okay, so which means we need to digitalize the data. So we need to provide the utility the data so they know where to solve the problem. Okay, so for Panjaya, this Panjaya is the largest water utility in Indonesia. So they target to complete the installation of the 1 million smart water meters until 2030. So this is because in Jakarta, the average about 40 to 50% of the population now still do not have the piping water. So the very important for the government is to pipe all the clean water to each household. So then it's a good chance that to install all the smart meters for the new household, and also we have to convert the existing household to the digital water meters. So we're talking about the digitalization. So then we have to talking about the technologies. So in currently there are quite many technologies like the MBLT, LoRaWAN, and C4, and even Wi-Fi, Bluetooth. So all can be available for the smart meterings. So why have to choose the LoRaWAN? So we have worked with utility from 2019 in Jakarta. So we start from the small project, from the POC, from the pilot, from the trial, and until the do the private developer project. So we start from 10 device, 100 device, 1,000 device, until 10,000 device for private project for over the 5 years. So over the 5 years, we sold to the government, we sold to the utility that LoRaWAN is the very reliable technologies that can be scalable to the citywide deployment. So that's why for the LoRaWAN, we all know about the advantage like the long range and low power and no cost for the operation. But the important is we to show to the government, utility how stable. So for them, the stable is one of the key considerations to deploy the whole city. So that's why Sindcon spent 5 years, over the 5 years, together with our partners in Indonesia to prove to the utility that LoRaWAN is the most reliable technology that we can trust and can be stable for next even 10 years. Okay, this is the first phase. So first phase, we already delivered 200K device, and installation is ongoing monthly. So now already more than 100K device already deployed across the Jakarta areas. So this is a really challenge. It's a really challenging work because a lot of unexpected environment that we have to encounter. We have to solve all the data transmission issues and data coverage, not only the coverage, but also the reliable of the network. So we also deploy the network server, LoRaWAN network server in Panjaya data center, because they do not allow the data to go outside the Indonesia. So all the data have to keep inside their premise. So we deploy the LoRaWAN network server in Panjaya data center. Okay, so besides the network coverage, besides the long range, besides the low power. Okay, the most critical for large deployment is the battery, because all the device, LoRaWAN device for smart water meter is battery power. So we not only to monitor the meter, but we have to monitor each battery device, such as the SOC state of charge and healthy, and how many remaining years they have, and what is the, let's say for PCB, because all electronic they got possibility to get fault or get problems in such hard environment. So we need to monitor each PCB got any issues in real time. So that's why Sindcon create this battery intelligent technologies. So we not only monitor the water consumptions, but we also monitor each battery. Although we all know about the LoRaWAN is a low power device. It's a low power technologies, but important is for such big scale deployment, battery is the key. So we need to monitor each battery in the schedules. So we cannot guarantee that 100% of the battery got no issues. This is a large scale, like 1 million device, but we must know when it got problem and when it could be problem. So this is a key for the smart device deployments. Okay, so this is the if you have any interest for the smart battery intelligence, you can visit our booth in LoRaWAN Alliance booth, so we can have more discussions. I will not talk more detail here. So let's do a quick conclusion for key takeaway to make sure the project, especially for the large project, citywide. We're talking about the citywide or national-wide deployment. The important is the system. I mean the technologies, the LoRaWAN should be scalable. So let's say we can increase from 1,000 to 2,000 to 10,000 to 100,000, 1 million, scalable. So this is very important. And the battery life cycle. We need to monitor each battery. If battery got gone, then of course no data. Then will affect the utility, the billing, So this is the key. And the local infrastructures. So which means for almost the utilities that I'm communicate, they all quite concerned about the data. So which means let's say they go to an MBLD or other public communications, then nobody who can guarantee the data, who can guarantee in the next 10 years the infrastructure is still there. So local infrastructure is very important for the utilities. This is very special for utility only. And also the eco calibration. Nobody can do the job for citywide by himself. We have to work together with local partners, ecosystems partners. So we work together to make success. So we work very closely from the semiconductor like STM, like ADI, and with to the local partners like our IoT Christie in Indonesia. We work very closely. We work together for more than 5 years to make sure this project can be success. And the last one is a long term. So for example, like the meters for utility, the water meter, they have lifetime maybe 8 or 10 years. So for telco, can I guarantee that 5G can be last for 5 years or 10 years? They can quickly upgrade to 6G or 7G or 8G. So only the private network like LoRaWAN, we can guarantee that it's more than 10 years. So that's the key takeaways. That's all my presentation. Thank you very much. Thank you.
So we have a couple of minutes for questions, but I will just fire a first question based on this example of successful deployment in Jakarta for Pham Jaya. we saw Sindcon, Kerlink collaborated on the same project with a specific aspect of the challenge for non-revenue water. You said 46% and more. What are to tackle this challenge of reducing non-revenue water? What specific actions have you been committed? Have you been asked by the utility to take?
Okay. So for non-revenue water meter is very complicated. The case is very complicated, but the solution is only one solution: digitalization. So we provide the real-time data and reliable real-time data. So first, they need to understand where is the loss and how much the actual loss. Then we can take the next actions. So this is the I believe in the past 5 years, or we already put to the utility. We do the private project and even trial in the utility project. So we put to them the real-time data is the key.
Real-time data.
Yes.
Yeah, that's important. And also for the network coverage deployment, it's difficult to balance between the demand for wide area coverage as well as for deep indoor penetration, which makes, for example, difficult to collect the water meter that is in water pit, etc. How did you tackle this challenge, Kerlink?
We always learn together with the partners what is the best coverage model. Is it ITM, COSHATA, or the others, which suitable with the network, and also to enrich the 3D data that can represent a blockage, attenuations, and with the right mindset, we find the good solutions. Always with also help from Sindcon team, they detailed everything, right? The factor that we need to achieve a really explicit result with this data formulations and coverage and predictions.
And there are maybe some mistakes that must be avoided.
Always,
Yeah.
from 100 try, we will get always one result good, but so then it's really messy. So I would suggest a good catalog for the try, for the attempt. Otherwise, we will stay late night to predict this.
And now moving to the smart grid monitoring, you explicitly mentioned PowerCo and other examples and the importance of this specific device for fault detection, etc. But can you also explain why, from your experience, utilities rely more on LoRaWAN than cellular for covering smart grid?
So there's a number of reasons. These utilities, especially the power utilities, have assets and networks. Their LV lines go all over the country, right? And some of it is covered by cellular network, and a lot of it is actually remote and can't get cellular connectivity. So for them, having a technology like LoRaWAN gives them a lot of flexibility where they can actually create custom coverage where they need to actually integrate sensors, whether it's their LV or substations. They also have a lot of issues around connectivity. It could be underground and so on, where LoRaWAN helps for them to be able to achieve that connectivity at a low cost. Where basically LoRaWAN is giving them a flexible coverage where they can create coverage where they want, but the cellular networks are fixed. So this is one of the key reasons for them. They see that flexibility of using LoRaWAN.
Thank you. And to take also an example from Itron experience, where you say that deploying a dual AMR-AMI means a meter that is ready for walk-by or drive-by until there is a fixed network available to collect the data. In your experience, you say that's a strategy to help the utility to go for smart metering with AMR deployment and being ready for future. With that, how is it important to maintain data continuity for these meters to move from AMR to AMI?
So primarily the reason the strategy is about the capex investment from the utility on the infrastructure today. We have, for example, some companies who have nationwide network for LoRaWAN, but most utilities would have areas which are rural and which won't have LoRa deployments from go one. So the intent is to have them read meters maybe a couple of months or a year, and the contracts would be on concession or long-term contracts between 10 to 15 years. That's what we see in most part of those Asian countries now, with the fundings coming from ADB and JICA. So when the contracts are so long, you can start at the basic reading for maybe monthly or quarterly readings on AMR, and so the software which Itron has maintains that the continuity of data, which is very important because the whole thing about analytics for non-revenue water depends on that continuity. So it's a very easy transformation from AMR to AMI when that is switched on and the network is available for LoRaWAN.
And I have a last question for Chen. With your success of 99% and more reliability for the data collection in this high-rise building, is that specific to this building or is it replicable to anywhere?
Yes, I have been, our project is starting in Vietnam, and then we rolling out in Singapore, Malaysia, Philippines at the moment. And most of the building, high-rising building, will have a similar characteristic of the technical room is on the same vertical across the building. And this why I think this make a lot of, it's the most suitable for electricity and water in terms of for the high-rising building. And also, it's not just one building, it's like many, some of the speaker before mentioned, the flexibility, the interoperability, because it's opening, and the scalable in across many building. Let's say in Philippines, we have some of the client we are working on, they have like own thousands of building across Philippines, and they want to be all in the same platform, all in the same connection, give the flexibility like Sourmack mentioned. So I think this should be the best, the most suitable one.
Thank you, Tuan. We are at the end of this session, but if there is maybe time for one question or two from the room, you can ask to the panelists. Here there is one question. If there is a mic, we can manage. Can you name yourself and ask your question, please?
Yeah. Hi, Remi. My name Suryo from Jakarta. Actually, it's very interesting hearing the solution from LoRaWAN. My question is basically all the connectivity or end devices is really need the gateway, and the gateway will be connecting to the optical or mobile cellular or any connectivity is already there. Basically, in our group, we are the biggest telco tower provider in Indonesia, and we have like 200 kilometers fiber optics already on the ground. And I think it's very powerful if the connectivity or the gateway can put on the BTS or on the tower to serving any utilities, even water, electricity, gas, whatever there. I think we need some session to discuss on the solution, and we can learning how other country operate and running the IoT using the LoRa technology, and maybe the question that I also want to asking, when you build the connectivity across the building, across the floor, are the LoRaWAN can penetrate beyond the concrete? That's the question. Thank you.
Okay, so the penetration, there is one example. Can you describe where you located the gateways in the high-rise building to path through the concrete walls and ceilings?
So our experience in the high rising is all of the building except for the basement, because the basement, the foundation of the building is very thick. So the basement is totally another building. So only of the rest of the building, I'm very confident that one of the we're using Kerlink gateway, and most of the time at least will be 5 floor up and down. So you one gateway indoor, you can go up to 5 floor up and 5 floor down. So it's 10 floor, can go up to 7 floor each up and down. And I think it can penetrate quite well, because in the same vertical of the high rising, you only need one gateway for that. So we're confident. We put it inside the technical room, and it still can go up and down 5, 7 floors. It's not an issue, and we can read all of the electricity and water meter within. But with the condition, it have to be in the same vertical. It will be easier where you cannot have 4G or NB-LT reaching there with the telecommunication. So I think that's our experience that we can deploy. So you still have to test, but most of the time at least 5 to 7 floor up and down.
Maybe quickly to respond, I'm Olivier from Semtech. I encourage you to go on the LoRa Alliance booth. There are a couple of demos. You will see, because LoRaWAN is using LoRa radio. You will see example of LoRa radio, and the performance going through the concrete is due to the radio performance. So LoRa radio. You will see this live on the booth.
The sensitivity and as well the multipass aspect of the modulation allows to go through concrete walls. There are examples also of implementation in nuclear plant where there are very thick walls of concrete to protect from radiation, and LoRa can be used to connect in between. Shall we stop here? Otherwise, you can upload the panelists for their effort in presenting to you these use cases. Thank you.